Vision, it's the primary sense for most of us. But for embedded systems, it remains a significant challenge. Here is a very nice little robot by Pololu. It can run around and avoid obstacles. But what if it could also see?
Hi, I'm Laurent Ity. I'm a vision scientist and creator of JeVois. My goal in life is to make machines that can see. Let's see what we have for you.
Introducing the JeVois smart camera. We have packed a quad-core processor, camera sensor, and USB interface in a tiny package. Here is how it works. You just insert a memory card that contains all the software, plug in your USB cable. There is no driver needed. It takes a few seconds for the camera to start up. When the red LED is on, you can then just start your favorite image capture software, and that's it. You are ready to go.
We are going to focus on high frame rates of 30, 60 or 120 frames per second. For that we are going to use low resolution imaging. So the pictures are not going to look very good to you, but the question is, can the machine interpret them?
Here we run a visual attention algorithm developed in my research lab. It quickly detects things that are interesting and would attract the human eye. We can then recognize those things, such as those robotics markers. JeVois is an open source C++ software framework for Linux. To get you started and inspired, we have already programmed a number of vision algorithms that range from QR code decoding to object recognition with deep neural networks. Here is the visual attention algorithm again running on the camera. Look at that frame rate. The demo display is created on the camera itself and directly streamed to the host computer over USB. Here we attempt to recognize up to 3 attended locations per frame, such as a light switch or doorknob. This is a multi-core processor, so let's also recognize faces. Look at the bottom right corner. Here I am. At the same time, we are here also recognizing handwritten digits. We are using a deep neural network to do that. Here I'm going to show a number of handwritten digits to the camera. That is number 2. Look again at the bottom right corner. How about QR codes? Oh, here we go, about 80 frames per second. Here we detect Aruco markers that are very popular in robotics and augmented reality applications. Very robust and very fast. How about some simple color-based object tracking? Yep, you got it. Here we detect and recognize pictures of things that we have seen before. This is a simple background subtraction algorithm to detect moving things. Here is an example of using Neon multimedia processor instructions. It works and is fast. Here we run 4 image filters on the camera's small GPU while also computing attention on the CPU. And finally, here is a demo of eye tracking, which is using image capture at 120 frames per second. Connecting the JeVois camera to your Arduino is easy, and you or it can talk to the camera through a little command line interface. You can also use that to stream data. Here, for example, we use a small Arduino to control a pan tilt head that will aim the camera towards the most interesting point according to the visual attention algorithm. For machine vision applications, full control of all the camera sensor parameters is essential, such as exposure, white balance, so we give you all that control. Alright, so let's look at a few real-world applications. This wearable application is inspired by research which we are doing for visual aid for the blind or visually impaired people. This is with support from the National Science Foundation. Here we detect places by QR codes. We can also do it by saving pictures of different places such as this nameplate. How about enabling some very interesting robots such as this one? This is going to be challenging. Yes, the pictures are clean. And now we can detect Aruco markers in the environment of the robot. Do you like autonomous cars? Okay, I'll do the throttle. The smart camera is going to do the steering. The smart camera is detecting lines on the road and computing the location of the vanishing point, which helps decide on the heading for the car. As before, we can also detect Aruco markers, barcodes, QR codes. Here is more example of driving on roads. And finally detecting objects. Yes, we found it. Because of its small size, weight and power, the JeVois smart camera allows you, for the first time, to run all kinds of algorithms on all kinds of hardware. Let's see if we can detect those arrows again. Yes, it looks okay, thanks to the very high frame rate at which we are processing. Here is another example in which we are going to detect locations that we have pictures from, for example that number 26. With JeVois, we are bringing the best of advanced electronic design, manufacturing, and scientific research to deliver machine vision for everyone.
Alright, so we have 3 basic usage scenarios. As a user, you can download apps and you are ready to play. As a developer, you can write your own modules. As a hacker, you can enhance the kernel drivers and also the JeVois framework.
We make it easy for you to write your own vision modules by handling all the details of the camera and USB. Here in about 20 lines of code, we implement a real-time edge detection algorithm. We believe this has huge potential, especially for kids to start experimenting with machine vision in all of their projects.
I'm very excited about this. If you like what you just saw, please consider backing us, and thanks for watching.